Good afternoon, Year 12. In today's lesson, we're going to spend a little bit more time looking at how we can model an annuity using a recurrence relation. So this follows on very closely to the work that you did last lesson. To start with, I want to have a look at this example that we have. Flynn receives a superannuation payout of $785,000 when he retires. He decides to invest this money into an annuity that will pay him $5,130 per month for the next 20 years. And we're going to look at how we might model that situation using a recurrence relation. So what we have here is Flynn has $785,000 that he receives when he retires. And he invests that into an account so that he will receive monthly payments of $5,130. And that's going to happen for the next 20 years. So the first thing we need to ask ourselves is this an example of an annuity? And I think we can say that it is, because we have equal, regular payments being made from this account. So he's receiving this payment every month, which means it's the same amount of money every month that's coming out of our account, which satisfies our definition of an annuity. So then if we wanted to model this situation using a recurrence relation, we might be tempted to use the recurrence relation for annuity formula that is on your formula sheet. And here it is here. It says that the next term is obtained by multiplying the previous term by our growth factor R and then adding our deposit. So that means we'd increase the balance of the account by the interest rate. That bit's fine. And then we'd add the payment. Is that what's happening in this situation? Is the $5,130 being added to his account? No. What's happening in this situation is that amount of money is actually coming out of his account every month because he's receiving that payment. So this annuity recurrence relation formula here that's on your formula sheet, it doesn't work for this kind of annuity that we have in this situation. Let's have a look at our recurrence relation for a reducing balance loan. It says to multiply the previous amount by the growth factor. That will increase it by the interest rate. That's fine. And then it says to minus the repayment, or payment in our case. That recurrence relation is going to model this situation because we have the $5,130 coming out of our account. So you need to be very careful with your annuities and modelling them using a recurrence relation that you don't just automatically go to this formula that's on your formula sheet because it doesn't actually apply to all our annuities. Let's have a look now at this a little bit more closely. On your notes, I gave you those two rules and I gave you a situation or a few different situations of when you would use those. So for this first type where we are subtracting the repayment or the payment, what we will find is that in this type, the payment is going to reduce the balance of the account because it's being taken away from the balance of the account. Two examples of that are a home loan, because when we make our repayments on a home loan, we are reducing the amount of money that we then owe the bank, which is the balance of our account. Or an annuity where you invest a lump sum of money now and then you receive payments over time. So that's the example that we looked at the beginning with Flynn. He invested $785,000 now, and then he received those payments over time, which meant that every time he received one of those payments, the balance of his account was decreasing because money was coming out of his account. You'll notice in pencil there I've written for you that both of those situations are a present value of an annuity, and we looked at that a little bit last lesson, and we will look at that in greater depth next lesson. So this rule here, it is written on your formula sheet as the recurrence relation for reducing balance loans, but you need to understand that it also applies to this type of annuity that we have as well. The other recurrence relation formula that's on your formula sheet is the one where we add the deposits plus D, and what will happen then is that the payment is going to increase the balance of your account because we're adding that money to the account. So our example of that is that we would make payments into an account over time and we'd receive a lump sum payment in the future. So that's like our superannuation account while we're working. Payments get made into our account while we're working, and then when we retire, we get to access that lump sum of money in the future. So that formula is on your formula sheet as a recurrence relation for annuities. Let's look at some examples and see if we can pick the right rule to use in each of these. So for each of the following annuities, we're asked to model the situation using a recurrence relation and use it to determine the balance of that account after 3 payments occur. So the first one is that example that we looked at where Flynn is receiving his superannuation payout when he retires and he's investing it so that he will get $5,130 per month for the next 20 years, and we have our interest rate there compounding monthly. So I'm just starting with this statement here to help me to work out which of the 2 rules I should use. Because Flynn is receiving these payments out of his account, those payments are going to reduce the balance of his account. So I'm going to use the rule that has the subtract the repayments in it, because I need to reduce the account balance by the size of those payments. We're very familiar with this, so I've used my interest rate to work out my R value, and I've put that into my rule, subtracting the payments of $5,130, and the initial value of that account is $785,000. This bit should be very straightforward to you by now, so we start with $785,000, we follow our recurrence relation repeatedly to get the balance here after 3 months. Just going to do a little bit of a reasonableness check at this stage. I was expecting that his account balance would be decreasing over time since he is withdrawing those amounts of money, and so I can see here that it is decreasing over time. The second question here, Molly invests $150 per week into a bank account. The interest rate is 2.8% per annum compounding weekly. So when I think about this situation, her payments, she's actually putting them into her bank account. So I think they're going to increase the balance of her bank account. So the rule I'm going to use is the one that has the plus D on the end. So I'm adding the payments to the end. Once again, I've worked here to find my R value, substituted it in, making sure that I'm adding my $150 payments this time, and the initial value of this account is 0 because I haven't been told that she has a certain amount of money in her account to start with, so I'm assuming it's a new account that she's starting. So the initial value is 0. Week 1, after 1 week, she has $150 in her account. And that makes sense if we look at our diagram here, because she started with nothing. And so in this first week, she's not earning any interest because she didn't have any money in the account. And then at the end of that week, the $150 has been deposited, which means she's now got $150 in there. After the next week, though, she's earned a little bit of interest on the $150 she had in there, plus the extra $150 payment. We can see that her account is starting to increase now. The last example, Alex borrows $15,000 for a car. He repays this loan with monthly repayments of $320. The interest rate is 4.6% per annum, compounding monthly. What are our payments doing to our account balance in this question? So he borrowed $15,000, and when he's making his repayments, that's paying off his loan. So those payments are reducing the existing balance of his loan, or how much he owes the bank. So I've used the rule that's a subtract. This type here will be a bit of a giveaway because it's talking about a loan, and your formula sheet says recurrence relation for reducing balance loan. So I don't think you're going to have a problem spotting when to use that one in this situation. So same process that we've followed here, subtracting the $320 payments, and the initial value is $15,000 because that's what he borrowed to start with. I've worked that through here to see that after 3 months his account balance will be $14,209.48, and I would expect that that would be decreasing over time. That's the end of the first part of our lesson, the main part of our lesson today. There's a worksheet on OneNote with 7 questions. I'm going to ask you to pause this video now and try those 7 questions and see if you can pick the correct rule to use in each of those 7 situations. And then once you've finished that, if you can come back and watch the rest of the video, there is another small thing that we need to go through. Hopefully you were able to do those 7 questions without any problems, and of course if you did have problems, make sure that you post them on the collaboration space for your teachers to help you with. The other thing that we need to look at today, just very briefly, is how changing our interest rate and our payment amount, how that affects our annuities. So I'm not going to refer to reducing balance loans at all, because we've already done that in a lesson a few lessons ago. So you can refer back to that if you need to refresh on what that was. But today we're just going to look at the 2 different types of annuities that we have, the present value and the future value. So just to remind you, the present value of an annuity, that's where you invest your money now and then you receive your payments over time. So your payments are coming out over time. What happens if I increase my interest rate? If I increase my interest rate, this account will be earning more interest over time. So if it's earning more interest, then the duration of the annuity will increase because I'll be able to receive payments for a longer period of time because the interest rate was higher and therefore I was earning more money along the way. What happens if I increase my payment amount? If I change my payment amount to a higher amount of money, that means I'm taking money out of my account more rapidly. And if I do that, then the duration of my annuity is going to decrease because I'm going to run out of money sooner. What happens if I increase the amount that I invest? So this initial amount of money at the beginning, what happens if I invest more at the beginning? Then the duration of my annuity, is going to increase as well because I've got more money in there, which means I'll be able to receive those payments for a longer period of time. Now, each of those that we've just discussed is based on the assumption that all of the other factors stay the same. So this is the only thing that changes. What happens for our future value annuity? This type is where we invest money over time, so we put money into our account over time, and we collect our lump sum payment at some time in the future. If I increase my interest rate, then that will actually decrease the duration of my annuity. So I'm working on the assumption here that I know I want my account to grow to, let's say, $50,000. So under the current circumstances, it might take 10 years to grow to $50,000. But if I increase my interest rate, then I'm earning interest more rapidly, which means my account is growing more quickly, which means it's going to reach that $50,000 sooner. So that decreases the duration of my annuity. What happens if I increase my payment amount? A similar thing will happen. If I increase how much money I put into my account, then my account is going to grow more rapidly, and once again, it's not going to take as long to get to that $50,000. So the duration of my annuity would decrease. Hopefully all of that makes sense. We've looked at those same concepts for all of our different types of investments and loans that we've looked at in topic 1. So it's important that you think about the situation that you're in and how your changing interest rate or payment amounts might affect that situation, because it is different for each of the different types of loans and investments that we've looked at. There aren't any questions as such for that little section, so if you finish the worksheet, you've finished all of the work for this lesson.